moving in to the next application of Pythagorean's theorem today. So what we learned yesterday was a squared plus b squared equals c squared, Pythagorean's theorem. And that Pythagorean's theorem is true for all right triangles. And you can do the converse, which means the opposite. If you're given a triangle and you're wondering if it's a right triangle, you can plug things into Pythagorean's theorem and see if it actually is or not. What you need to remember today, A and B create the 90-degree angle. So today we're going to apply Pythagorean's theorem with word problems. So anytime that you're given a problem today, you think to yourself, how can I make a triangle out of this? There's a certain vocab word that's aligned with this. We use Pythagorean's theorem to measure distance. Distance is the quickest way to any destination. Now think about this. Pretend this is me, but pretend this was SAC and pretend this is the high school. If I said, hey, I want you to walk to the high school, the quickest way to walk to the high school is to cut through the field. Do you agree with that? It's not the only way, it's the quickest way. You could also walk from SAC down to School Street and then go from School Street to the high school. Can you see the triangle that's formed? So now let me reiterate here. The quickest way is to cut a diagonal, but really that diagonal always creates some kind of 90-degree angle. You have to find it. So I could also walk from here to here. There's my 90 degree. Distance is really the hypotenuse. Although it's longer than from going from here to School Street or from School Street to the high school, it's really shorter because here you'd have to walk there plus walk there. Okay. The vocab word that you look for to know you use Pythagorean's theorem is the word distance. That's why I kind of boxed that off. Distance means Pythagorean theorem. It means that diagonal measure to get from one place to another. Okay, let's practice this. Let's say that John leaves school to go home. He walks 6 blocks north and then 8 blocks west. How far is John from school? So I'm going to go ahead and put school here. I always start with my vertices if I have them. So here John starts at school and he walks north and then he walks west. So 6 blocks north, 8 blocks west. Do you see the right triangle? Do you see it? Yes. Yeah. I want to know how far is John from school. My right angle is right there. So that's my A and B. I'm looking for the hypotenuse. So I know that 8 squared plus 6 squared is equal to that C squared. I'm just going to plug it into my calculator just like this. It makes it a little faster. 8 squared plus 6 squared is 100. So C squared is 100. C is the square root of 100, which is 10 blocks. And I knew that I was using Pythagorean's theorem. Well, first off, I knew because it was talking about those distance. Remember, the distance is north, south, west, east. And also it said how far. How far represents the distance. Next one, a 13-foot ladder is placed 5 feet away from the wall. The distance from the ground straight up to the top of the wall is 13 feet. Will the ladder get to the top of the wall? So this one's kind of weird, and it's typed weird. Let's make a wall. There it is. Let's make a ladder. around it. There, I made a ladder. It doesn't have to be nice. You just have to envision it. So I know that the ladder is 13 feet. I also know that it is 5 feet away from the ground. Can you see the right angle? Yes or no?
Yes.
That's always what your eyes are going for. Can you see the right angle? The distance from the ground straight to the top of the wall is 13 feet. Will the ladder reach the top of the wall? I mean, obviously, right? Because, I mean, here you don't have to do much math, but you know you use Pythagoreans theorem because you have the right angle. So it would be the 13 squared plus 5 squared, and it's not equals for this one. It's okay if a ladder is a little bit above the wall, isn't it? It's okay if you're on a roof and the ladder goes above a little bit. You just get off before, you don't climb to the top where there's just air there. You would just get off a few steps early. So I want to know, is that bigger than or equal to 13 squared? Anyways, it is. I mean, you don't see many like that. That's not going to happen much today. But you will see one like the next one.
No.
What is the perimeter? Remember, that's adding around. In the area, base times height divided by 2 of the following triangle. So I'm missing some dimensions, and I'm just going to label the dimensions. I'll let this be x. I'll let this be y. I need both of them. I have to. I have to have y in order to find perimeter, because I have to add around. I have to find x to find the perimeter, as well as to use it for the area. You know, it's base times height. So this one's kind of a multi-step situation. You just pick a variable to start with. I'll go with x. So you should envision the right angle. So I'm going to use this triangle. So my x and my 10 create the right angle, so those are my a's and b's. So x squared plus 10 squared equals 12 squared. X squared plus 100 equals 144. X squared is 44. X is the square root of 44, which is 6.6. So this measurement right here is 6.6, whatever the units is. I also need y. So now I see the other right triangle I can make. Looks like y is the hypotenuse because 8 and 10 create the right angle. So 8 squared plus 10 squared equals y squared. Doesn't matter what you call it, A, B, C. Well, I guess I don't want you calling this A or B. But C, X, it really doesn't matter. Y. So 64 plus 100 is y squared. Y squared is 164. Y is the square root of 164, which I don't even know. But now I do, it's 12.8. So now my y is 12.8. All that work only to now be able to actually start solving what they wanted me to solve. They wanted me to find the perimeter. So the perimeter of this, add around. So my perimeter would be 12.8 plus 12, and now the bottom. The bottom is two parts, 8 and the 6.6. So plus 8 plus 6.6, right? So what do you think that is? 15.4. No.
Get that in my head.
No way. 12.8 plus 12 plus 14.6 is 39.4.
Oh,
Okay. Now I solved part 1 for perimeter. Now I need to find area. Base times height divided by 2. So the base of this triangle, base is equal to 8 plus 6.6, which is 14.6. And now I can use a formula. Base, 14.6, times height, 10, divided by 2. Is 73. So maybe I'll box off everything I found. That's what I was looking for. Perimeter and area. Kind of messy. So I didn't have much room. But it was definitely a multi-step problem. That's like level 3.5, 4 there. That's great. Last one. Frank's school is due west of his house and due south of his friend Scarlett's house. The distance between the school and Scarlett's house is 4 kilometers. And the straight line distance between Frank's house and Scarlett's house is 5 kilometers. How far is Frank's house from school? Oofta, I got a lot going on here. I'm just going to start one at a time. Frank's school is due west of Frank's house. So here's Frank's school. It's west of Frank's house. So his house is right here. Do you agree with that? His school is due west of his house. And due south of Scarlett's house. So that means that his school is south of Scarlett. That means Scarlett is north of the school. Do you see your vertices for a right triangle? Do you see them?
yes.
Can you envision that right triangle? I can too. There we go. Now I can just fill in blanks. Let's see. The distance between the school and Scarlett is 4 kilometers. So 4 kilometers from Scarlett to school. I label my vertices. I would highly suggest doing that because it can get really confusing if you don't. And the straight line distance between Frank and Scarlett, so Scarlett and Frank, is 5 kilometers. How far is Frank's house from school? So Frank to school. I'll call it X. Or B or A, I don't care. I say B or A because there's that right angle and A or B created. So 4 squared plus X squared is 5 squared. 16 plus X squared is 25. X squared is 9. X is 3. Taking that square root of 9 is 3 kilometers. And that is your learning target for today.
Cool.